Okay. Hi, today we are going to see about the rectifier in detail. Okay, so already we know that to convert the AC into a pure DC you need three different blocks. One is a rectifier, second one is a filter, and third one is a regulator. Okay, so what is the function of the rectifier? So in the last video I have told that the function of the rectifier is to convert the AC signal into a pulsating DC, not a pure DC. Okay, so the rectifier, this is a circuit which converts the AC signal into a pulsating DC signal. So it will not give a pure DC waveform. Okay, so you all know that AC signal means a pure sine wave. Okay, and the DC means a pure DC wave. This is a pure signal. Okay, so this rectifier will convert the AC into DC, but it is not a pure DC. Its output is like a pulsating DC. Okay, so in the rectifier, based on the how many number of diodes you are going to use in the circuit. Okay, see how it will convert the AC into a pulsating DC with the help of a diode. Okay, so we already know that diode is a single conduction, that is unidirectional conduction diode, that is a diode. Okay, so the function of the diode is it will conduct only in a unidirection, right? So how many number of diodes you are going to use in the circuit, based on that this rectifier is classified into a main two categories. One is a half wave rectifier and another one is a full wave rectifier. Okay, so one is a half wave rectifier and another one is a full wave rectifier. Okay, here in the bracket I have mentioned one, right? So this one represents that means you are using in half wave rectifier you are using a single diode. Okay, so again see this FWR means full wave rectifier. So this full wave rectifier is categorized into two types. One is center tape rectifier and the second one is a bridge rectifier. Okay, so again here in the bracket I have mentioned the number. This number represents that how many number of diodes you are going to use in this particular circuit. Okay, see in the half wave rectifier you are using only one diode, and in a center tap rectifier you are using a two number of diodes, and in a bridge rectifier you are going to use a four number of diodes. Okay, so based on the applications you can use which rectifier you need. Okay, this is the rectifier. So rectifier means it converts the AC signal into a pulsating DC with the help of a diode. Okay, so base for a half wave rectifier you are using a one diode, and again the full wave rectifier is categorized into two types, center tape and bridge rectifier. So the center tape rectifier you contains a two number of diodes, whereas in the bridge rectifier you are having a four number of diodes. Okay, yes. So now we will see about the principle, construction and operation of half wave rectifier. Okay, see in the half wave rectifier already I have told that you will use only one diode. This is the diode. Okay, this is the PN junction diode, that is a semiconductor. PN junction means nothing but a normal semiconductor diode. Okay, so this is the positive direction and negative direction of the diode. Okay, clear? So positive means nothing but the anode, negative means cathode. Okay, so this is the diode. See here, this half wave rectifier principle is it converts the AC signal into a pulsating signal only a positive half cycle of the applied AC voltage. That means here see, this is the construction. Here you are having a transformer. So the input of the transformer is a single phase AC supply. Okay, that means your input is a AC signal. Here the construction you see, it contains a step down transformer and then single semiconductor diode, then one load resistance RL. Okay, so what is the step down transformer? So you all know about the transformer. Okay, so from the transformer only we are getting the supply to our home appliances, right? So here see, this is the number of turns. Okay, so in the step down means, so you are going to reduce the voltage supply. Okay, if you want to reduce the supply voltage means you have to use the step down transformer. Okay, so if you want to increase your voltage, increase your applied voltage means then you have to use the step up transformer. Okay, here see your goal is to convert the AC into a DC. Okay, so you are using a step down transformer. Step down means here in the diagram itself you have to draw clearly. See, this is the number of turns. right? So this number of turns is maximum in the primary side when compared to the secondary side. Okay, so here this is the primary means input, secondary means output. Okay, so this number of turns is always maximum in the primary side, that is the input side, when compared to the output side, that is the secondary side, while in which case step down transformer. Okay, so this number of turns, by seeing this number of turns one can identify which kind of transformer you are using in this particular circuit. Okay, see, this is a step down transformer. So here this number of turns is maximum in the input side and minimum in the output side. You have to draw like this. Okay, see, for example, if you draw like this means it is wrong. Okay, see, here the number of turns is minimum in the primary side. This is a step up transformer, not a step down transformer. Okay, so in a rectifier you are using a step down transformer, one PN junction semiconductor diode and another one is a load resistance RL. Okay, clear? So now here your input is a AC signal. Okay, so AC signal means now what? So during the positive half of the cycle, this is the positive half. Okay, and this is the negative half. Now your input is what? Single phase AC supply. This is your input. Okay, this is a time and this is the voltage. This is your input. So your input is like this. Okay, so in the x-axis time and in the y-axis this is your input voltage. Now at first time, that is during the positive half of the cycle, so it is enter here like so. Now this is the positive and this is the negative. Okay, so during the positive half of the cycle, so this is positive and already we have seen in the PN junction diode, this is the positive and this node is the negative. Positive is also called as an anode and the negative terminal is called as a cathode. Okay, so the PN junction diode, we are having a two terminal, one is an anode, another one is a cathode. Okay, so you know what is meant by forward bias and reverse bias, right? So now I'll tell you, if you don't know means just you should know that, because without knowing the function of the diode you should not understand the concept of the rectifier. Okay, see, this is the diode. Here you are having a two terminal, one is a positive terminal and another one is a negative terminal, right? So this positive terminal, this one is a positive. So if the positive is connected to the positive means then this condition is called as a forward bias. Okay, only under the forward bias the current will conduct. Okay, then you will, that means you will get the output waveform. So during the positive half of the wave, this is positive and this is the negative terminal. So here see, positive is connected to the positive terminal of the diode, so automatically this is a closed switch. So your circuit will be like this, closed switch, and you will get the output waveform here. So for your positive half of the cycle you will get the positive half of the wave. Clear? Yes. So now during the negative terminal, so now the positive of the wave is entered, right? So during the negative half of the cycle, that means now your input is a negative, right? So now here this is not the positive terminal, this is negative and this is the positive. Okay, so now because this negative terminal, negative half of the wave is entered as an input, so now this is a negative and here what is this? This is a positive. So positive and negative means opposite direction, right? So now this particular diode will act as a reverse bias. So under reverse bias, here it is a open switch condition, not a closed switch. This switch will get open and there is no current conduction along this path. So you will not get the wave when the negative half of the cycle is entered as an input. Okay, see, again your positive half of the cycle is entered as an input, then you will give the positive half of the wave. So this wave continues. Okay, see, only you will get the output when you enter the positive half of the cycle as an input. That's why this is called as a half wave rectifier. Clear? So what is a half wave rectifier means? What the principle? The principle is to convert the AC into a pulsating DC only during the positive half of the cycle. Okay, so during negative half of the cycle, the diode does not conduct. This is the main principle of the half wave rectifier. Okay, and its construction and operation means in the constructions you are having a one step down transformer, one single PN junction diode, then one load resistance. Okay, so step down transformer means what? The number of turns is maximum in the primary side when compared to the secondary side. Why? Because you are going to reduce the voltage. That's why you are using the step down transformer. Okay, then what is the function of the PN junction diode? It will conduct only in the forward bias, and there is no current conduction in the reverse bias. So what is the forward bias? If the positive terminal of the supply, that means this is your diode, right? This is the positive and this is the negative. If your positive terminal of the is a positive negative, if your positive terminal of the diode is connected to the positive terminal, then it is called as a forward bias. Okay, the opposite case is considered as a reverse bias. Okay, so during the positive, that means during the forward bias you will get the output wave, and during the negative half of the cycle this diode will act as a reverse bias. Okay, that's what I have written here. During positive half of the wave, the diode will act as a forward bias. That means it is a closed switch condition and the current conduction is there. You will get the output waveform. And during a negative half of the wave, so this PN junction diode will act as a reverse bias, and this is a open switch condition, so there is a no current conduction. Okay, clear? Thank you. So in the next one we will see about the half wave, full wave rectifier.